In a previous video lecture, I discussed convex lenses, the kind of lens that bulge out on either side. The opposite sort of lens is called a concave lens. It caves in on both sides. Let's take a look at some of the properties of concave lenses. There's your axis of the concave lens. The center of the lens is there. There's a point on the left side of this lens called the focus or focal point. What's special about it? I'll explain. I show a paraxial ray, number one, a ray parallel to the axis. And I show a second paraxial ray, ray number two, also parallel to the axis. Ray number one, after it passes into and then out of the lens, will have been refracted, bent, along this path there. Similarly, ray number two will have been refracted along that path. If one extrapolates back the rays 1 and 2 on the other side of the lens, they intersect at a common point on the axis called the focal point. All paraxial rays incident on a concave lens will be bent in such a way that they appear to come from a common point on the other side of the lens called the focus. That's one of the two special ray behaviors that you need to understand in order to successfully create and interpret a ray diagram which will reveal the characteristics of the image formed. The second of the two special rays is the center ray. It's the same special ray that you may recall we talked about for convex lenses. Rays aimed at the center of a concave lens go straight through, are not bent, not refracted. That's what's shown here for rays 1, goes straight through, and ray 2 goes straight through. Let's use these two properties to learn how to construct and then interpret the image formed with a concave lens. I show a concave lens. There's its axis. There's the center. I have a focal point on the axis, and I use that vertical arrow there as, or to simulate an object that somebody whose eye is over here is looking at through this concave lens. I have it as upright, and it's that tall, labeled O for object. Now, we imagine that this object arrow is in sunlight or room light, overhead lights. Light is reflected off the top of that object arrow and reflected in an infinity of different directions. We'll just follow two of those rays, the special rays that we talked about a minute ago. First, we have a paraxial ray, ray number 1. It's bent and extrapolated back. According to this eye, the ray of light number 1 could come from any point along that line that's infinite. The second ray that goes straight through also reaches the eye, and according to the eye, that source of ray number 2 light could have come from any point along that line there stretching to infinity. The actual apparent origin of the light, the two rays of light that reach the eye, is found by extrapolating backward. This is automatically extrapolated back to the intersection point. It's at that location there that the image is found to reside. What can we say about this image? It's shorter than the object. It's upright. And it's not real. You can see that it's not real because there isn't really light coming from this place. It only appears to be doing so. The eye that sees this ray number 1, there's no light traveling along this path to the eye. And so this is not a real image. It's called a virtual image. All concave lenses form this type of image. The images are always upright no matter where your object is, and the image is always virtual, not real. And it's always shorter, as I may have already said. That concludes my discussion of concave lenses.